Welcome back to the Agentic AI Podcast. I'm your host, and if you're tuning in, you're probably trying to find, the real signal and all the noise of enterprise automation. We usually talk about the flashy stuff here, the generative design, the customer service bots, things you can really see. But today, we're going into the basement. We're talking about log management.
It does have that reputation, doesn't it, for being the driest topic in all of IT.
Dry. It's practically arid. But here's the hook, and this is why we're doing a whole session on it. In the banking world, those boring text files are the only thing standing between a bank and, well, massive regulatory fine.
Or worse, a complete fraud meltdown.
Exactly. So the mission today is to get past this idea of just, passive storage.
Right.
We're looking at agentic intelligence. We're going to dissect how AI agents are now reading, reasoning, and actually acting on these logs to satisfy some of the strictest regulators out there.
And that shift, from passive collection to active reasoning, that's the single biggest change in this space in probably 20 years. But before we even get to the agents, we have to respect the problem. We have to talk about the sheer magnitude of the data.
Right, because I think when people hear logs, they're picturing a little text file on their laptop.
Yeah, system update complete.
Exactly. But a big bank isn't dealing with megabytes. They are generating something like 2 terabytes of log data every single day.
2 terabytes. It's a staggering amount of text.
Mm-hmm.
And if you think about the velocity, it's coming in at a rate of about 100,000 messages per second.
100,000 messages a second. It's a wall of noise. You can't just have a guy named Dave scrolling through a terminal window looking for errors.
Poor Dave would be catatonic in seconds. I mean, it is humanly impossible. And that really brings us to the core problem of the last decade, which is alert fatigue.
Right. When you have that much data, the old rule-based systems just scream at you constantly.
They do. And it's not just the volume, is it? It's the complexity. We're not running on monolithic mainframes anymore where everything is in one neat place.
Not at all.
No. The modern infrastructure is, well, it's a fragmented mess, but by necessity. You've got Kubernetes clusters spinning up containers that might live for 10 minutes and then just vanish.
And virtual machines, API gateways, talking to who knows what third-party vendors.
Right. A mix of operating systems, RHEL, Ubuntu, Windows servers, all shouting their status updates at the same time in different formats.
It's a cacophony. And somewhere in that 2 terabytes of noise is one tiny little signal that says, hey, someone's trying to brute force the credit card database.
Precisely. And the traditional setup, what we've used for years, the ELK stack.
Elastic, Logstash, Kibana.
Yeah, it's fantastic for search. If you know exactly what you're looking for, it will find it. But it fragments the data. It creates these silos. And when you have silos, you get incomplete audit trails.
And incomplete audit trails are just a nightmare scenario when the regulators show up. Let's talk about them for a second, because the stakes here aren't just we might get hacked. It's we might lose our license to operate.
The regulatory landscape has tightened, immensely. If you look at the Reserve Bank of India, the RBI, they have a strict requirement that incidents must be reported within 6 hours.
6 hours for a huge organization? That seems incredibly tight.
6 hours from detection. And on top of that, you have to keep all your security logs for 2 years. So you have this massive historical archive, but you need to be agile enough to find a problem and report it before your workday is even over.
So if I'm the CSO at a bank, I've got 6 hours to find the needle in a 2 terabyte haystack, figure out what it means, confirm it's real, and then write a formal report to the government.
That is the reality. And it gets even tighter. You look at PCI-DSS for payment cards.
Right.
Requirement 10 mandates a daily log review. Every single day you have to prove you reviewed the logs.
A daily review of 100,000 messages a second. That sounds like a punishment from Greek mythology.
It is. It's Sisyphus pushing a rock up a hill, but the rock is made of server error codes. Most places doing this manually are just, they're just ticking a box. They aren't finding anything. They're just saying they looked so they don't get fined.
And then you've got ISO 27001 and SOC2, which are all about evidence. Tamper-proof proof.
Exactly. So the insight here is pretty clear. Meeting a 6-hour reporting window or doing a daily review, it's just a math problem. And the math says it's impossible at this scale without something smarter than a keyword search.
You can't just grep your way out of a regulatory fine. You need actual intelligence.
Which is exactly why we're seeing this huge shift to agentic AI.
Okay, let's get under the hood of this. This is the Agentic AI Podcast, so let's talk architecture. We're not just talking about a better dashboard. We're talking about AI agents. What's the base layer? What are we building on top of?
So in a modern stack, you usually have A few key components. You'll have something like gray log for aggregation. That's like the catcher's mitt that grabs all the logs.
Oh.
Then open search for indexing, so the data is actually searchable.
And something to get the data there in the first place.
Right, that's where Fluent comes in as the forwarder. And for storage, which is a huge concern.
Storing 2 terabytes a day is not cheap.
No, and it's risky. So you often see Minio for snapshots. And critically for banking, everything is encrypted. We're talking AES 256. Plain text logs are a non-starter.
Okay, so that's the chassis. Graylog, OpenSearch, Fluent. Now let's put the engine in. How is this agentic? How is this any different from a simple Python script?
This is the critical distinction. A script is linear. It follows a predefined path. If this, then that. An agentic system uses frameworks like React.
React. That stands for reasoning and acting, right?
Correct. So in a traditional script, if the error doesn't match the exact rule, the script just fails or does nothing. An AI agent using React enters a loop. It looks at a log entry, and it reasons about it. It asks, what does this actually mean?
And then it decides on an action.
Exactly. Maybe it queries another database. Maybe it checks a different log file to see if there's a correlation. It observes the result of that action and then reasons again.
So it's iterative. It's basically mimicking how a human analyst would think. Hypothesis, test, conclusion, but at machine speed.
And you're also seeing frameworks like Codact, which allows for parallel execution. So while it's reasoning about one thing, it can be executing code to pull data from another source.
It turns the AI from a passive reader into an active investigator.
That's it.
But how does it handle the messiness? I mean, server logs are not clean. They're full of hex codes and timestamps and weird error strings.
That's where the NLP, the natural language processing, comes in. The AI parses all that noisy, unstructured data to extract the 5 Ws.
Who, what, when, where, why.
All right. It turns a string of garbled code into a simple sentence. User admin failed login at 2:00 p.m. on server B.
Okay, let's ground this with an example. Because reasoning can sound a bit abstract. Walk me through a real-world bank scenario.
Sure. Imagine a payment gateway fails. A customer tries to use their card, and it gets declined. In the old world, the war room scenario, an analyst gets an alert. Transaction failed. So they have to log into the application server, then the database logs, then maybe they call the network engineer. It can take hours to find the actual break.
And meanwhile, the customer's angry and you're losing transactions.
Right. Now, an agentic AI sees that payment failure. It immediately uses that React loop. It thinks, okay, payment failed. Was it the database? It queries the DB logs. Nope, DB is fine. Then it asks, was it the network? And it correlates the timestamp of the failure with the network latency logs.
Ah, so it's cross-referencing everything in real time?
Exactly. It sees a spike in latency at the exact millisecond the transaction failed. It identifies the root cause network latency instantly. It presents the human analyst with the answer, not just the problem.
Wow. That's like having a detective who's already solved the case before you even walk onto the crime scene.
That's a great way to put it. And when you map that capability back to the regulations we talked about, the value just explodes.
Let's do that mapping. We mentioned the RBI's 6-hour reporting window. How does an agent help there?
Well, the RBI demands a root cause analysis, an RCA. If your AI has already done that correlation we just talked about, the RCA is basically 90% written for you. A human isn't spending 4 hours diagnosing. The AI provides the data for the report immediately.
So it's automating the bureaucracy.
It is. And for repetitive issues, it can handle automated ticket creation, which aligns with what's called KMP logging corrective and preventive action. The compliance trail is built automatically.
Okay, what about PCI-DSS, the daily review nightmare?
Yeah, and the benchmarks here are pretty clear. AI correlation can cut those review times by about 50%. The biggest problem with PCI is false positives. An old system might flag every single time an admin logs in at night.
Which is technically an anomaly, but it's usually just someone doing scheduled maintenance.
Exactly. The AI learns patterns. It knows admin Dave always logs in at 10 p.m. on Tuesdays to patch the server. It suppresses that alert. But if admin Dave logs in at 3 a.m. from an IP address in another country, it screams. It filters the noise so humans can focus on the real threats.
And what about ISO and SOC too? You mentioned explainability is key. Executives are terrified of black box AI.
As they should be. Auditors do not trust black boxes. You can't just say, the AI said it's fine. The agentic AI creates a clear, human-readable narrative. It says, I detected this anomaly, I checked these 3 sources, I found this correlation, and I determined it was a false alarm. That narrative is the evidence.
That's a huge difference. It's not just giving the answer, it's showing its work.
Precisely. If you can't show your work, you fail the audit.
Okay, this all sounds fantastic, but I can hear the decision makers listening to this getting nervous. We're talking about banking data. PII, personally identifiable information.
Right.
You cannot just send your transaction logs to a public LLM.
Absolutely not. That's the quickest way to get shut down by a regulator. Data exfiltration is the elephant in the room.
So what's the solution? How do you get the brains of an AI without the risk of the public cloud?
The solution is all in the deployment strategy. You're looking at either air-gapped or a strictly on-premise setup.
Air-gapped meaning completely disconnected from the public internet.
In this context, yeah. It means the data never leaves your controlled environment. You bring the model to the data, not the other way around.
And what about the data itself? Even on-prem, you don't want the AI reading raw credit card number.
No, of course not. Use PRI filters. Before the log data even gets to the analysis layer, you mask those sensitive fields. Credit card numbers become asterisks, names get hashed. The AI analyzes the patterns of the data, not the sensitive content.
So it can still see that someone accessed 500 records in a minute, which is the anomaly, without knowing what was in those records.
That's it, exactly.
Now, running these models on-prem, that takes some serious hardware, doesn't it?
It does. You need significant GPU resources. Or you use secure managed services like AWS Bedrock, where you have legal guarantees your data isn't being used for public model training.
In our research, a tool called lowtouch.ai's Graylog AI agent came up as a good example of this kind of dynamic querying.
It is, yeah. It's a great example of an agent that sits on top of that Graylog architecture we mentioned. It lets you ask questions in plain English, and it executes those complex React loops for you.
So we've covered the tech, the regulations, the privacy. Let's talk ROI. If I'm a CTO, why am I signing the check for this? Besides, the fear of going to jail.
Fear is a great motivator, but the hard numbers are there too. First, incident response times. We're seeing around a 30% reduction. When you're bleeding money during a transaction outage, 30% is massive.
No, really, time is money.
And second is uptime. Predictive monitoring can facilitate 99.9% uptime because you're catching that network latency before it becomes a full-blown outage.
But there's a cultural ROI here too, right? We joked about admin Dave, but burnout in security teams is a huge problem.
It is. And developer productivity is the hidden win. Automation frees your best engineers from manual log trawling. Nobody gets an engineering degree to stare at text files all day.
They want to ship code.
They want to build things. You take the drudgery of compliance off their plate, and morale goes up, and shipping velocity increases.
That's a great point. But, and I'm guessing there's a but, this isn't set it and forget it, is it?
No, and I cannot stress this enough.
But the human element, I was waiting for this. We're not firing the security team.
Absolutely not. The AI is a force multiplier, not a replacement. You need human oversight. You need a human in the loop to address biases, to verify those explainable insights.
So the AI says, I think this is fraud, and the human says, okay, let me double check that logic.
Exactly. Or the AI flags a new type of transaction as an anomaly, and the human provides the context saying, no, that's actually our new product launch. The AI handles the volume. The human handles the nuance.
It's a partnership. The AI is the exoskeleton, but there's still a person inside driving it.
That's the perfect analogy. It's a symbiotic relationship.
So let's zoom out. We started by saying logs are boring. I think we've proved they're actually the central nervous system of a bank.
They are. We're really witnessing a synthesis here, a shift from logging for storage, just to have the files, to logging for intelligence.
The logs aren't a data graveyard anymore. They're a real-time active asset.
That's the takeaway. And looking forward, this is only going to accelerate. The next step is predictive analytics. Not just something broke, but something is about to break.
Fixing compliance breaches before they technically even happen.
Right. Pre-crime for IT, in a way. And it raises a really provocative thought for everyone listening.
Okay, here we go. Lay it on us.
If Agentic AI can continuously prove compliance in real time, if it can show you, second by second, that you're following every rule, does the whole concept of the annual audit become obsolete?
That is a massive question. Why stop for a yearly inspection if you're inspecting yourself every single millisecond?
Exactly. Continuous compliance could just end the era of the frantic pre-audit scramble.
I love that. A world without audit panic. I think every banking executive listening just breathed a sigh of relief.
We can hope.
Well, that brings us to the end of this episode of the Agentic AI Podcast. We went from 2 terabytes of noise to a streamlined, intelligent compliance machine.
It really is a brave new world for log management.
Thank you for tuning in. And remember, the logs are talking. Make sure you have an agent that can listen. Keep automating.